Hey guys, so for this video we're going to start a three-part series on partitioning. Partitioning can be one of the trickier concepts that we do in high school geometry, and I'm hoping that by breaking it down into three different parts, it can help break down the process for you. So the first part of really being able to do partitioning properly is to understand ratios and use ratios. So here I have a full line segment and I've spaced it out so it looks like we have little individual pieces, but that's just so that you can see it to be able to break it down and understand it a little bit better. So if I consider this segment, the whole segment, to be from A to C, I can see that from A to C breaks down to 1, 2, 3, 4, 5, 6, 7, 8, 9 equal pieces. And if I look at the segment from A to B, this section, I can see that that takes up 4 of those sections. And then I can see over here from B to C that that accounts for 5 of those sections. So what you need to be able to do in the questions that you're asked about partitioning is to write that in different ratios. So I'm going to give you some examples so you understand what I'm talking about. So if I said, what is the ratio of AB to AC? If I asked you for that ratio, you would say that that ratio is 4 to 9. I could also ask you for the ratio of AB to BC. So that ratio from AB to BC would be 4 to 5. Additionally, I can switch the order. So I could ask you for the ratio of AC to AB. So that's the same things I asked you about in the first one, but order matters when you're dealing with ratios. So I would have to put the 9 first because there's 9 equal sections compared to 4. Another way they sometimes write the ratio is talking about the part compared to the whole thing, and they'll write it as a fraction. So I could say that AB is 4/9 of AC. So AC is all 9 pieces, and AB is 4 out of those 9. So when we're talking about things, we're really concerned about which ones are the parts and which ones are the whole thing. So in this one, the whole thing is AC, and the parts are AB and BC. So therefore, this ratio is a part to whole. This ratio is part to part. This ratio is whole to part. And this kind of equation here, or this setup with a fraction, is part to whole. So if I was to look at these examples here, so if you look at the top, I said, given that AC is the whole segment, I want us to interpret just these words here. So the problem is they don't come with this lovely little diagram showing you the individual sections. But I encourage you to make your own whenever you're trying to solve them. So if I look at this one, it says AB is 3/5 of AC. Now we know that AC is the whole thing. And so if this number on the bottom is the denominator, that's going to be that whole thing. So from A to C is 5 sections. And A to B is only 3 of those sections, the numerator. So you could put B right here. And if I asked you to write this instead of as a fraction, if I asked you to write it as like a ratio, you could say that the ratio of AB to AC is 3 to 5. You could also talk about other ratios. You could talk about the ratio of AB to BC. That would be 3 to 2. Or you could talk about the ratio of BC to the whole thing. So BC to AC would be 2 to 5. And that's how you can kind of flip between those. The most important one for when we're solving our problems that you're going to see, typically the most important ratio you can write is the one that compares the part that you're working with to the whole thing. So in this one, from AB to AC is a 3-to-4 ratio. So because AC, I said again, that was the whole segment, and each question that you deal with is going to have contained in the directions what the entire segment is called. So you're going to use that to determine what the whole segment is. It's going to be based on the problem that you're working in. So AC goes with the 4 because that's the second segment listed. AB goes with the 3 because that's the first segment that's listed. So if I was to draw a diagram to help you kind of understand that, the whole thing is going to be 4 sections from A to C. And we know that B is going to be 3 of those sections. So from A to B, it's going to be 3 sections. So I could list another ratio. I could say AB to BC is 3-to-1. I could even say that AB is 3/4 of AC. I could say, like I just said, AB to BC is 3-to-1. So there's a lot of different ways that you can work with that. Like I said, the most important one is the part to whole. In this one, I didn't give you the whole thing. I said AB to BC is 3-to-4. So if that's the case, and we know that the whole thing is from A to C, well, if you were to draw this out, AB gets 3 sections, and from B to C gets 4 sections. So if I asked you for the part to whole ratio, AB to AC, what do you think that would be? What do you think it would be to talk about the part that's AB compared to the whole thing that's AC? So hopefully you said that that would be 3-to-7. And then this last example, it says AB is 3 times as long as AC. And that example doesn't go well with everything I was doing. Sorry, it should say AB is 3 times as long as BC. I apologize. So if AB is 3 times as long as BC, now in none of these do we have AC. None of these, either AB or BC, those aren't the whole thing. So you could draw it where AB gets 3 sections, so that's from A to B, and then BC just gets 1 section, because from A to B would be 3 times the amount of BC, which is 1. You could make life harder on yourself. You could make this, 6 sections. You could make this 2 sections. It would still work out to be a 3-to-1 ratio. And then if they asked you, what's the ratio of AB to the whole thing? Hopefully you can see if AB is 3 times the size of BC, then the whole thing is actually 4 sections long. So AB would be 3 compared to AC, which is the whole thing, which would be 4. And what we're going to do as we get into more complicated problems is these segments aren't just going to be drawn for you just in space. They're going to be on a coordinate plane, and we're going to have to manipulate them and work with them. But even if we're talking about something with coordinates and we're on a coordinate plane, I still always draw this little diagram of little dashes to help me start and figure out what my part to whole ratio is, because that's the most important part. So to move forward with partitioning so you can solve all of the problems in our class, check out my next video, and I'll see you guys soon.